Welcome, welcome back to Twitch Live. We're so glad to have you guys at reInvent 2017. I'm excited, hopefully you are. I'm really excited because I have some really cool people with me to introduce right now. We have Richard. You know what? I'm not going to do it. You're so fantastic. You introduce yourself.
My name is Richard Threlkeld. I work for AWS Mobile on the product team, and I'm joined here by Rohan.
And my name's Rohan Deshpande. I'm the lead for this new product we're launching, which we're going to tell you in a few seconds. I've been at Amazon and launched quite a few services, so I'm always excited to launch new services.
Yes, new services are exciting, and we have one exciting one here today. So, drum roll, please. Do you guys want to? I'm going to let you do the honors. Do you all want to announce your new service that's launching today?
Thank you, Tara. The service name is AWS AppSync. And this is a managed GraphQL service running on AWS. Specifically, it meets the GraphQL spec, but also has some unique features, both around real-time capabilities, as well as offline support that we've added in. We've also enhanced it with our specific AWS flavor of enterprise security, such as using AWS IAM for using AWS credentials, as well as Cognito user pools for doing fine-grained authorization.
Okay, so tell me, I kind of know what's cool about GraphQL, but tell the AWS public, what can they expect that's going to be really cool that they can develop on and do now that we have this great new service?
Sure, yeah. So GraphQL, it's a new technology, a couple years old or so. Specifically, it's caught on a lot in the front-end engineering community and mobile developers. And the idea behind it, first of all, it's not a graph database. It's specifically like the application graph that you're building. So you can use relational stores behind it. You can use DynamoDB, NoSQL stores. What we've opened up with AppSync is you can create data sources for DynamoDB, Elasticsearch, and also AWS Lambda here at launch. And the idea is that it's a declarative language that you can specify the data needs of your application. So instead of all your implementation about what records you're going to send over the network and so forth and being encoded on the back end, they're defined by the client. And so now you get a lot of rapid prototyping, flexibility in your applications. You get better behavior on mobile devices from bandwidth and CPU perspective and battery.
So you said better performance, how does that work? So if I want to develop an app, and obviously data inputs and outputs are the hardest thing to drain your performance or have a performance bottleneck. How is this going to benefit me? If I'm coding up, I'm going against you said I have the ability to go in the database, so I kind of know, but yeah. But what is going to be really the benefit of me? I'm building this app, I need this data. How is it really going to help me? And of course, there's multiple platforms I have to go across.
Sure, yeah. So a couple of things on that, kind of unwinding it. First is what we've enabled and built as this platform, leveraging GraphQL, is we support the full spec, meaning GraphQL queries and mutations for kind of request response, getting data, even pagination and so forth, and making changes, as well as a subscription channel that you can get real-time updates to your app. So by using our SDKs on multiple platforms, iOS, JavaScript frameworks for web, as well as React Native and so forth, you can essentially define your data that's going to be larger in bulk or paginated through, or that you want queries and to be persisted, and then the real-time updates, which are small deltas coming over the channel, rather than spewing everything everywhere and just having a lot of noise on your network. Additionally, what we've enabled for you from a cross-platform standpoint is, I mentioned that this service allows offline communications, right? Now, offline's really important, and in fact, there's a lot of overlap between real-time and offline services when it comes to applications, right? You might have a news feed, and your news app, that needs to be real-time when you're connected, but you want to read your data when you're offline as well. Maybe you want to make comments on that news feed and things like that. You want your UI to get updated when you're offline as well, or it could be some shared document collaboration. So traditional systems kind of offload these issues to the client to handle, versioning, and if you have multiple people making updates, you have to deal with conflicts, and conflict resolution is on the client. Instead, we've actually moved this to the cloud, and we have different phases of conflict resolution that are in the cloud service, so it doesn't matter what clients connect to them. You can define what data you want to be, kind of your bulk data or come over queries, and what data you want real time that absolutely needs to be resolved in the UI as soon as it's available, and then also have a unified story when it comes to offline and conflict resolution.
Okay, that sounds pretty cool, don't you think so?
Yeah, I have a lot of questions about how the offline works. So you get the hooks in your app to react to the circumstances, and you get notified when things change, is that it?
Yeah, so a few different things with offline. So one is we have plugged into some of the common frameworks. For instance, we plug into a popular GraphQL client known as Apollo, and we published some plugins to this as part of the launch. And realistically, just to have data readable offline, all you need to do is instantiate our client, pass in your credentials, and then just pass it to what's known as the provider in the application, and your data is readable offline. You as a developer don't need to do anything.
Okay, so that sounds great, but I actually want to see, you know me.
And you want to see some real-time stuff.
I want to see some real-time. I
Yep.
believe in looking at the code. So are you guys going to show us something live today?
We're going to show you something live around real-time here.
So let's see.
So we switched over?
So why don't you switch over to the demo?
Cool.
Go over the slide.
So really quick before we get into the demo, the flow is we support GraphQL spec, as I said, and we allow you to upload GraphQL schemas either from CLI or using our built-in editor, which has linting and things like that in the console using the GraphQL SDL or schema definition language. What's pretty cool about this is you can bring your own resources like DynamoDB and Elasticsearch, or you can press a button and provision resources from a GraphQL schema. Like you press a button, it shows you what queries will be associated with your tables, and then we deploy DynamoDB tables from that. Once you do that, it literally is just hooking up your clients, and Rohan's going to demo this for you now.
Okay, yes, I want to see this live.
All right, well,
Show us the goods.
that was the demo, so I think we're done here. But cool. So let's start with the demo. So what we have here is we have a React web app. Prove that it is because I've just run yarn start and it's running. And then we have a React Native app that's running in iOS, which is subscribed to the same AppSync endpoint that we have. So the way this works is if I tap here, this should synchronize real time, and then you'll see my iOS map move. Maybe I need to refresh it. Subscriptions tend to be slow. Okay, let's try it again. So if I tap anywhere, what this is doing is it's sending a GraphQL mutation. The mutation gets stored in DynamoDB, and then it goes into Elasticsearch using DynamoDB streams. And then it gets synchronized through the real-time channel over subscriptions that the client app is listening to. And it works two ways. So if I tap there, that's one way to do it. Let's say I just tap here, you'll see a second spot showing up over here. It's pretty, you can't see it, it's right behind here. But I can keep tapping here and keep tapping here. You'll see my clients move.
Ah, I see it. Okay, I see
as
the
the real-time
movement.
state
Yeah,
is changing.
okay.
So the way, and of course you can be anywhere. So let's say we wanted to, just a more compelling demo because I have a lot of items here. Let's go to, click around Oakland maybe. And you can assume this is going to be like a retail store where you're purchasing and you have like a real-time dashboard of purchases that are happening. So in this case, let's say someone purchased something near Oakland, and you can see you can have like a read-only view maybe on your client where you get a real-time view of the changes that are happening which are going through the AppSync system. So looking at the code, let's go to the code really quick. So this is the React Native app, and usually if you wanted to add real-time subscriptions, you want to add the ability to write changes, it's non-trivial. With the SDKs we're releasing and with the AppSync service itself, it's actually fairly simple now. All you do is instantiate this AppSync client, and then you write your GraphQL mutations and queries, whatever you're interested in. So this mutation is whenever you tap, it sends the write to the server, and then it gets synchronized across. And then the subscription is you're listening to any updates that happen to that tap mutation. And that's really all you need. The rest to just subscribe, you add this one line here, you add a subscription handler, and this is where you get the data, and then all I'm doing is updating my local state, and I'm moving my map in response to whatever the state changes. From a mutation point of view, just call client.mutate, pass in the queries and the fields that change, the variables that change, and again, that's all you need to do. So it's really like maybe 4 or 5 lines of code you need to write, and you get a fully functional, scalable, secure, real-time system which works cross-platform across Android, iOS, React Native, browsers, and it just works. It's got the power of AWS behind it. Let's go with the AppSync console really quickly because this is how you probably start working with it. So you create an API. We've got a few APIs here. The sample app is hooked up to the MapTap application we've built. And what you get here, so we've got a few data sources here. Like I said, the data is stored in DynamoDB, so we have a tap table. That's our DynamoDB table. The searches go through Elasticsearch, so we've got an Elasticsearch cluster set up. And then we have a Lambda function hooked up as well. The Lambda basically emulates did a purchase go through successfully or not, and returns back a Boolean right now. So it's just basically proving that yes, you can hook up to a trigger if you wanted to. From a schema point of view, define a GraphQL schema. This is defined in the schema definition language, which is a GraphQL standard. And so we've got a location type, which is a latitude and longitude. So whenever you tap, the map returns the location, the latitude and longitude, which then gets written through the mutation. And then you have your tap entity. This is the key entity. So this represents every tap that you make in the system. And then you have a bunch of fields in there. You have a unique identifier, so you can track it cross-platform. If you have an identity, let's say we were able to log in using IAM or Cognito, which is supported in AppSync, we could pass in an identity, so you could do things like, only send events to Rohan if he's subscribed and if he's authorized to get those events. You can actually get fine-grained access control. This is the location, so this is the actual latitude, longitude where we tap. He has a timestamp, which is a local timestamp, and he has a process flag, which is the Boolean for did the event actually, did the purchase actually get processed or not. Way you define a mutation, again, pretty simple. You just write the tap, and it's like a standard JavaScript function. And then you have a few queries here, which are used by either the client, by the native client, or the web client. So we do taps near, so you can do a geo search using Elasticsearch, and then you can do like a global taps that are searching across everything. So once you've got this schema, now we've got data sources, we've got schema set up, you hook them up together using resolvers. So let's take a look at the queries we have, because those would be probably the most informational resolvers. So our tap table is hooked up to a DynamoDB table. And what the resolver is doing is it takes the data source we set up. You create a mapping template using Velocity templating language. This is similar to API Gateway's language, so you should be pretty comfortable and familiar with it. And then you can set up your operation, you can set up some fields that you need. In this case, we're doing just a simple scan. So you just do a scan template, and really all you need to specify is limit next token, maybe that's optional. We have a bunch of templates here for different use cases, so you don't have to write this yourself. You can just pick one of these, and it should just work out of the box. In terms of response, right now we're just taking all the items that come back and return them. But again, there's different ways you can do this. So if you want to do paginated results, you can have a template for paginated results. And these templates are based on the data source we're looking at. So if I go to my Elasticsearch, which is doing my geo queries, you'll see the templates are slightly different here. In this case, this is a search template that goes to Elasticsearch, but it's a geo search, so it's actually using the Elasticsearch DSL. So if you're familiar with the Elasticsearch, you don't really need to learn yet another language. You just need to wrap around your DSL with the right VTL, and you should be good to go, and you get all the functionality you need right out of the box. So the point is you can take your own data sources, and you can put AppSync in front of it, and you can then aggregate across all these different data sources using a common single type structure and a schema. So we've got this, we've got the apps, we also have an editor built in, so you can run queries if you wanted to. So let's just do all taps, and we want to do ID, let's say we want to do location, and all I really care about that. So one of the cool things about GraphQL is your client can actually control the structure of the data that comes back. If you build this as any other service, like REST service or a SOAP service or whatever, the response structure is well defined, and you get back everything that's defined in the response itself. You can't select what you need.
I think what I liked the most when I was playing with it was the fact that after I set up the schema and things of that nature, it literally had the intelligence to tell me, okay, these are the values already that you have set up in your schema. And I thought that was really cool as you're quickly testing and doing this in the console. So kudos to that.
So one of the cool things about GraphQL is it encourages self-documentation, and it has this concept called introspection. So when you create your types, you automatically get this documentation explorer, this library of all the functionality of defining your schema. And if you drill down into the queries, you'll see, hey, look, we have taps in here, and you can have the comment, right, which shows up as documentation. So you basically are writing a self-documenting schema and a system right with it. If you wanted to see, the mutations, I had a tap mutation here in this case. I can drill down into the types. It gives me all the information I need. We haven't done a great job documenting our sample schema, obviously, but best practice would be you would have actual documentation on each of these things in Markdown or whatever, so there's enough context. And as you write your schema, you're also documenting the schema at the same time. So going back to this query, I just had a simple query. Let's run it. this is going against the same Dynamo table that my mobile app was going against, my React Native app was going against. So this is a quick way for you to play around with the schema, run your queries, make sure everything is working, and then once you're good to go, you can then go and actually just take these bits and add them to your application, and everything just works. So the one part I didn't cover yet was subscriptions, the real-time piece, like how am I sending data back and forth. So the way you do that is you have a subscription type, and you attach this subscription handler to a mutation. So with AppSync, what you do is you don't just get an arbitrary stream of events that are happening across the server. You're getting events that you're interested in that are only in response to changes that you're interested in. So in this case, all we care about is the tap mutation, right? So anytime I tap anywhere, and it doesn't matter what data source it's on. We completely abstract away the concept of data sources, so anytime you make a change, it flows down to any connected client.
I think what was also cool about this is, for instance, tap is not a typical data scenario, it's an event that fires, and the fact that you can respond to a tap, which we typically think of as a behavior, for data, in response to data, is pretty fantastic to me.
Yep.
So.
Exactly, you think of it more as a trigger instead of an event stream, and that's probably the right way to think about it conceptually.
Excellent.
I have some questions about how it works with DynamoDB. So you still have to manage your own DynamoDB, the service, and your own data source, right? So it's just a GraphQL interpreter on top of the data source, then you have to manage your own DynamoDB or Elasticsearch.
Yeah. So the resources are still in your account. And this was one of the things that we worked with a lot of customers to figure out, how they could start really low cost and scale their business as appropriate at the legitimate times when their business starts to take off. So because we support a couple of these provision flows, we can automatically provision, so you can get started without thinking about what a primary key is or anything else like that. But as you graduate and your business grows larger, there are resources in your account, so you can own and control them. You could hook up DynamoDB streams to do other things. One of the popular scenarios that we document is people doing write operations and individual item operations to DynamoDB, but you hook up a DynamoDB stream that goes to Elasticsearch. So every time that data changes, it results in Elasticsearch, and then you can have basically a combination of them from a single GraphQL endpoint with a couple of GraphQL queries.
And another questions about security, the security model. Do you have any overview of how that works?
Yeah, definitely.
Do you want me to cover it?
Yep.
So let me show you from the settings, I guess. If you go back to the demo.
So we're going to go back to the demo? Okay, cool.
Yeah. Cool. So AppSync comes with 3 auth modes by default. So we give you API key, which is really intended for development. So this is a quick way, you just embed the API key, it's an X API key header, and you can access the schema, and you have identity built in. Then you graduate to IAM, so you have full IAM support with deep dish, with AppSync. So you can set up resources, you can add permissions to operations, you can block certain users, you can have resource policies, the full power of IAM is available to you. And then you have federated authentication and fine-grained access control using Cognito user pools. So if you wanted your own managed directory, you wanted to set permissions based on groups that people are in. So like Tara and me could be editors on a blog, and we have read and write access to everything, but Richard is a reader only. You can set that with Cognito user pools. You can place people in the right groups, and we can set up access on the operations so that we can only perform certain sets of operations.
So since you mentioned blog, I am going to hit live blog, the blog post for this great new service, Amazon AppSync right now. So check the blog out for more details. So since we mentioned the blog, I got to hit post on this new blog post.
Do it.
Right? Shout out to the blog team for us working with these great teams to get it out. We went purple for the blog. Okay, I don't see you purple around here. I want to see more purple, guys. Do you have any more questions coming from the stream? We got a purple one in the audience, so purple for the blog, guys. Okay, any more questions from the stream?
No, that's it for us.
Okay, cool. You want to tell us anything else about the service?
The last thing that we'll just bring up is the service will be going live in the next 24 hours. You might see it in your consoles later tonight. And you can sign up. We're actually a public preview here, so basically just put in your information on a page, press go, and then we give people access in different batches. So if you're interested in this, please reach out to us, and we'll Additionally, along with the things in the console that Rohan just showed, we will be publishing several comprehensive examples to GitHub as part of the release as well on different platforms across different languages.
Hey, I want to code some stuff against it. So, we have another question?
Yeah. A lot of questions about region support and how, especially, and if this is a regional service, when it's offline, does it cares about regions and how this works?
So it is a regional service. We're launching in IAD, CMH, or Ohio, and PDX today. And when it's offline, it's actually very interesting. All the data that's returned from a GraphQL query is cached offline. So you could have results coming from DynamoDB, results coming from Elasticsearch, results coming from Lambda. It doesn't care about the region. That's locally cached. Essentially, we back that by a persistent store. On web, it's going to be SQLite. On React Native and the native platforms, it's going to be, it's going to be SQLite on those and local storage on the web platforms. But essentially, if your endpoint isn't available, then you can still operate as normal, and the customers writing their apps don't even realize it.
I see. Awesome. Thank you.
Excellent. All right, guys, that is it for us. Join us more live, more launches, more goodness here on Twitch. See you soon.